Welcome back, everyone. In this video, we're going to work on solving a formula for a variable. We have a lot of experience at solving an equation, just solving, and that means find the number or numbers that make the equation true. The word solve in math has a handful of different meanings. When we say solve a formula for a variable, what is meant is we want to apply the algebraic steps that we know to rewrite a formula so that a different variable is by itself. So for example, in this first one, we have A equals 1/2 B times H. That's the area formula for a triangle with base B and height H. It says we want to solve this for B. So what that means is we want to rewrite this formula so that the B is by itself. Right now, the A is by itself. And on the right side, we have 1/2 is multiplied by B, and that's multiplied by H. We want to end up with B equals something. Okay, so the steps to take are really similar to what we've done before, only our answer here is not going to be just a number, it's going to be another formula or equation. So here we're going to first multiply by 2 to clear the fractions out. So we'll have 2a equals bh. And then this one is not too bad. Right now, our target variable, b, is multiplied by h. To undo multiplication by h, we're going to divide by h. So we're going to end up with b equals 2a over h. And that's it. So we've succeeded in solving our formula for b. What's the difference, by the way, between a formula and an equation? A formula typically has more than one variable in it and often has some sort of real-world interpretation to it, like this one being the area formula for a triangle. Okay, so we've solved this one for B. Next, we have the formula relating Celsius and Fahrenheit temperature. Right now, it's solved for F. That is, given a Celsius temperature C, we could calculate the Fahrenheit temperature F. But let's say that we have a whole page of Fahrenheit temperatures and we want to figure out what the corresponding Celsius temperatures are. It would be helpful to have a formula that goes the other direction. This one turns Celsius to Fahrenheit. We need to figure out how to turn Fahrenheit into Celsius. So we want to get the C all alone. So let me first subtract 32 from both sides. So F minus 32 is 9/5 C. And then in order to make the C all alone, we can multiply both sides by 5/9. So make sure to multiply the entire both sides by 5/9. So then on the left side, we have 5/9 F minus 32. And then on the right side is just our C. Okay, so there's our formula that turns Fahrenheit into Celsius. By the way, if you're doing problems like this on an online homework system, not doing it like a paper test or paper homework or something, you have to pay attention to how the software is expecting you to enter your answers. For some of them, they may give you a whole answer box like this, in which case you would type in the entire 5/9 F minus 32 is equal to C. And then on others, they may have the C equals and then the answer box, and you only type in the 5/9 F minus 32. If it was this second type, where it said C equals, and I typed in the C equals 5/9 F minus 32, it's going to end up marking it wrong because of that extra C equals in it. So make sure and pay attention to your surroundings when you're working on online homework. Is it just a big empty answer box where you type in the whole thing, or did they give you part of it already done? Okay, so just pay attention to that. Okay, so next up, we're going to solve this one. A is equal to P plus P times R times T. This is a equation relating interest on an amount, a principal of P at an interest rate R. At a time of T, we'd had a formula for interest for before that calculated just the interest. A here, that's the future amount. That includes the principal. You can see that it's principal plus the principal times rate times time. We want to solve this one for P. I'm going to do this wrong first, and then I'm going to do it right. So let me do it wrong first so that you can recognize it. So let me mark this one as wrong. So at first glance, I might say, okay, well, I see this P right here, right after the equal sign. So let me subtract the P times R times T from both sides. And there it is. P is all by itself. While I didn't break any rules of algebra to do that, you can always subtract or add stuff to both sides. What's wrong with this is the fact that although the P is by itself, there's still a P on the left side. When we're solving a formula for a variable, not only are you getting that variable all by itself, you also need to make sure that none are left over on the other side. So that's the piece that's wrong on this one. Okay. So how to do this right? So how to do this right, we need to end up with just one P. So to do that, let me first rewrite the entire formula. So to do this right, you'll see that this formula has on the right side two terms, each of which has a P in it. So what we'll do is we'll factor the P out, and that'll make 1 plus RT. That turns the two P's into a single P. And then all we have to do to finish this is divide by that binomial 1 plus RT. So we have A over 1 plus RT, and that is our P. Okay, notice that here we have the P all by itself, and yet there's no P's left over on the other side. Another question can come up, is this right, or should the P be on the left? I suppose since we're solving for P, it's probably more polite to have the P on the left, but technically both of those are correct, okay? Let's do some more examples. One other thing to be aware of is that when you were solving equations before, we were able to just say solve because it was kind of obvious which variable you were supposed to find out the value for. For example, if it were 3x plus 1 equals 13, and I say solve, everyone knows that we're looking for what the value for x is, right? So it wasn't necessary to say solve for x, although we could have. In problems like we're working on now, we pretty much have to say what variable we're solving for. If I just said solve 4x plus 7y equals 9, you have to say, well, do you want it solved for x or solved for y? So for this one, we're going to solve it for both. Let's first solve it for x. So we'll have 4x equals 9 minus 7y. I subtracted the 7y from both sides. And then we'll divide by 4. So we have 9 minus 7y over 4, and that's our x. Okay, now we're going to solve it for y. 4x plus 7y is 9. This time we want the y by itself. So we'll subtract the 4x from both sides. So we'll have 9 minus 4x over 7. Okay, so how do you know which one you want? That depends on what it is that you're trying to do a lot of the time. In this particular example, the second form might be nicer for graphing. In general, it depends on what it is that you're trying to do. For our present purposes, you're pretty much going to be told solve for x or solve for y or solve for whichever variable. All right, so continuing onward, the next thing that we want to look at aside from solving for a variable is some formulas from geometry that involve solving for a variable. And we'd already seen the formula for the area of a triangle, A equals 1/2 base times height. And we're going to just apply it a few times to find the areas of a couple of triangles. Okay, so for the first one, we have a base length of 10 millimeters and a height of 7 millimeters. So the area is 1/2 the base times the height. If you're just getting to learn a formula, it's a nice idea to just write the formula every time you use it, and then before you know it, you're going to know what that formula is by heart. So we have 1/2 times 10 times 7. And 1/2 of 10 is 5. 5 times 7 is 35. That will be 35 square millimeters for the area. Okay, so now you can pause the video and try this second one, and then restart it and see how you did. Okay, so I've repeated the formula again just for practice. I've got 1/2, the base here is 9, and the height is 4. Remember to apply helpful rules whenever you can. Here, 1/2 of 9, 9 is not even, so it's not going to divide by 2 very easily. But I do remember that multiplication is commutative, so I might as well consider that to be 1/2 times 4 times 9. And 1/2 of 4, everybody knows, is going to be 2. So that's a lot easier. 2 times 9 is 18. That's going to be 18 square centimeters. Okay, just a couple of examples where we found the area of a triangle. All right, continuing our look at triangles. The angles inside of a triangle always add up to 180 degrees. Right triangles have a 90-degree angle in them. And so for a right triangle, here's one. You'll see a little box in the corner that indicates where the right angle is. If the angles all together add up to 180 degrees and 90 of them are taken up in that corner, that means that the other two angles have to add up to 90. So that's something to know. All right, so let's try a couple of examples. By the way, when angles like this add up to 90, that means that they are complementary. By the way, again, with spelling complementary, this complementary has an E in it, as in the sense of like completing something. It's not complementary with an I in it, like a free angle complementary. Okay, so there's that. So here we would like to find the size of angle X. So we know that the total of the angles has to be 180 degrees. So we'll just add them up. X plus 70 degrees plus 60 degrees equals 180 degrees. Combining like terms on the left side, we'll have 130 degrees. And so that makes X have to be 50 degrees. So 50 degrees the size of our missing angle. Okay, this one is a little fun because the angle inside of this triangle is not given to us, but we know that a full rotation is going to be 360 degrees, and a straight angle or a half turn is going to be 180 degrees. That's what's we have going here. That's a straight line, and so that whole angle has to be 180 degrees. And so if we want the part that is inside the triangle, that has to be the rest of it. Let's introduce a helper variable on this one. Let me call this angle A. So I know A plus 133 has to equal 180. So then A will be 180 minus 133. So that looks like it's 47 degrees. Okay, once we know it's 47 degrees, we can proceed in the same way as we did our previous example to find the value for X, which is what we really wanted. Okay, so I'll have X plus 74 plus 47. That's going to equal 180 degrees. So X will equal 180 minus 74 plus 47. So let's see what that works out to be. Looks like 59 degrees. So a couple of examples where we were finding angle sizes in a triangle. As I'd mentioned, angles that add up to 90 degrees are complementary. Angles that add up to 180 degrees are supplementary. So in this example, the 133 degree angle and the 47 degree angle are supplementary because 133 plus 47 equals 180. Okay, so that's the end of that. All right, so a nice word problem. Here it says the measure of one angle in a right triangle is 50, that should be 50 degrees, 50 degrees more than the measure of the smallest angle. We want to find the measures of all three angles. So it's a nice idea to make a sketch sometimes. That could be helpful. So we know that there are three angles in a triangle, and this one in particular is a right triangle. So making a sketch here. That one is 90 degrees. If the angles inside a triangle total 180 and that one's 90, then the other two have to be less than 90. And so the two remaining angles are smaller than 90. One's bigger, one's smaller. So we're going to pick a variable to be one of those. So which one? It says the measure of one angle in a right triangle is 50 degrees more than the measure of the smallest angle. So what they're referring to as one angle is bigger than the smallest angle. I'm going to use x be the smallest angle. Okay, we could make it be what they're referring to as the one angle, but usually it's easier to make the variable be whatever the other quantities are described in terms of. So one angle, it says one angle. Now I need to express the other quantities in the problem in terms of the one we have. Okay, so one angle is 50 degrees more than the measure of the smallest angle. Okay, so we have x, we have 50 plus x, and those two have to be 90, right? X plus 50 plus x have to total 90 degrees. So 2x plus 50 is 90. So 2x is 40 and x is 20. Okay, so now we have to make sure to summarize all of this correctly. So it says find the measures of all three angles. So x, that was the smallest angle, that one is 20. The next one is 50 more than that. 20 plus 50 is 70. And then it was a right triangle, so the third angle had to be 90. Okay, so there's the sizes of all three angles. Okay. All right, more examples to come. The next part is on the Pythagorean theorem. The Pythagorean theorem is named after a Greek mathematician named Pythagoras. And the fact of the theorem goes like this. If you have a right triangle, then the side lengths are related by this formula. A squared plus B squared equals C squared. The kind of typical first example that you see of this is of a 3, 4, 5 right triangle. A triangle with sides of length 3 and 4 and a hypotenuse or long side of 5. Why? Because 3 squared plus 4 squared is 9 plus 16, and that's equal to 25. 25 is equal to 5 squared. Okay, so that's an illustration of how the Pythagorean theorem works. The Pythagorean theorem goes both directions. If you have a right triangle, the side lengths are related by this formula. And additionally, if you have a triangle whose sides are related by this formula, then you're guaranteed that it is a right triangle. Okay, so let's try. Next, we want to find the length of the third side for this triangle. So one leg is length x, one is 12, one is 13. So we'll have x squared plus 12 squared is equal to 13 squared. So we have to solve for x. X squared plus 144 equals 169. X squared equals 169 minus 144, and that is 25. Okay, so x is 5. I know that there are two square roots of 25, 5 and negative 5, but here we're talking about a length which is positive, so what we seek is just the 5. That's the length of that third side. Okay, here are two more. For this one, what's unknown is the length B to C. I'm going to call that x. We'll have x squared plus 12 squared equals 15 squared. Okay, so that will be x squared plus 144 equals 225. So then x squared will be 225 minus 144. So that is 81. And so x has to be 9. Okay, so the length of BC is 9. Okay, here's one for you to try. This time the hypotenuse is unknown. So take a minute, pause the video, and try to solve this on your own, and then restart the video and see how you did. Okay, so let's try. We will have 10 squared plus 24 squared is equal to x squared. So that will be 100 plus 576. That will be x squared. X squared will be 676. Okay, so let's see what that works out to be. $26. Okay, so the length of that hypotenuse is 26. Okay, by the way, as you're working through these, a quick check would be to make sure that in this case the hypotenuse has to be the longest side. So we'd better get an answer that's bigger than both 10 and 24. And in our previous example, we had gotten 9. That had better be smaller than 15. Hypotenuse, the side opposite the right angle, is always the longest side. Okay, almost done. Okay, the next example is about a rectangle. So here it says the length of a rectangle is 7 more than twice the width. And the perimeter is 110 inches. We want to find the length and width. So here, notice again, we're trying to find two things, both the length and the width, but we're going to do this with one variable. So we're told that the length is 7 more than twice the width. So I'm going to let W be the width, and then we'll describe the length in terms of the width. So if W is the width, the length is 7 more than twice the width. Okay. The perimeter for a rectangle is the distance around. We'll have a width, and we'll have 7 plus twice the width. So there are 4 sides. 2 are W, and 2 are 7 plus 2W. And we're told that that perimeter equals 110 inches. Okay, so just backing up a little bit, we set a variable to be one of the things that we're trying to find. I chose width because in the first sentence, the length is described in terms of the width. So it's going to be easier to make the variable be the width. Okay, so then we describe the length in terms of the width in symbols. I drew a little picture because that helps me. I labeled the width side and the length side. I know that the perimeter for a rectangle is the distance all the way around. We have 2 of the width, we have 2 of the length, that equals 110. Okay, so this is an equation just in W's that we can solve. So I'm distributing to remove parentheses. We're going to combine like terms. And then let me subtract 14 from both sides. So W will be 96 over 6. And that is 32 times 3. That is 2 times 3, 16. All right, so that's part of it, right? The width is 16. And the units are inches. The length is 7 more than twice that. 2 times 16 is 32, plus 7, that's 39. Okay, moving along. We have triangles, or a triangle. One side of a triangle is 3 feet less than the first side. The third side is 5 feet less than twice the first. So 2 of the sides are described in terms of what they're calling the first side. And then the perimeter, we're told, is 20 feet. finally, the question part, find the lengths of the sides of the triangle. So what they're calling the first side, I'm going to make that the variable. So x will be the first side. Okay. All right, so now what they're saying is one side is 3 feet less than that first side. So x minus 3 is the one side. And then the third side is 5 feet less than twice the first. So twice the first minus 5, that will be the third side. So we have expressions for all three side lengths. We know that the perimeter, that's the distance all the way around, has to be 20 feet. So let's add them up. We have x plus x minus 3 plus 2x minus 5. That will equal 20. So we have 1, 2, 4 x's minus 8 is 20. 4 x's is 28, so that x is 7. Okay, so then we can do that to figure out the three side lengths. We know that x is 7, that's the first side. X minus 3, 7 minus 3 is 4. 2 times 7 is 14, minus 5 is 9. So our three side lengths are 7, 4, and 9. Seven feet, 4 feet, and 9 feet. Okay, again, make sure if you're doing this kind of thing on like some online homework or something, they may have 3 separate answer boxes here. One for the first side, one for the second side, and one for the third side. Make sure that you put the right answer in the right box, otherwise it's going to charge you for that. So the first side ended up being x, that was 7. The one side is 4, that was, I would call that the second side, and then the third one that they mentioned, yeah, third side was 9. Okay, all right, so that takes care of that example and also takes care of this whole section. So we're all done. We started with solving a formula for a variable, and then we moved on to looking at some geometric formulas for triangles, including angles and perimeter, and then a little bit about rectangles. So that takes us to the end. If you have any questions, let me know. Otherwise, have a great day.